Chapter 5. Water supplies for your fire protection systems. Our objectives: define the terms pressure, flow, and duration as they relate to the movement of water. Identify and describe the components of a water supply and distribution network. Discuss the differences between a municipal and public water system and a private water system. Describe how pumped, gravity, and combined supply systems operate. Define friction loss and discuss how it affects water flow. Define the terms static pressure and residual pressure. List and discuss the characteristics of the two types of NFPA-approved stationary fire pumps. Define the terms churn, rated performance, and peak performance in relation to stationary fire pump testing. The water demand of a community changes throughout the day, week, month, and year. Engineers need to determine the sources that will meet the community's current and future needs. If the delivery system is adequate to support manual firefighting and water-based fire suppression systems. Needed fire flow. The number of gallons per minute the fire department will need at a particular location to fight a fire. Not a measurement of water needed for a fire suppression system. The fire flow models use various factors, including type of construction, size of the structure, occupancy conditions, and communication between buildings, and of course, exposures. The same delivery system that supplies water for the community's domestic, commercial, and industrial needs also supplies water to water-based fire protection systems. The ability of these systems to protect hazards depends on whether or not the water delivery system is capable of supplying the pressure, flow, and duration necessary to support the proposed design of the fire protection system. Determining the adequacy of the water supply is one of the most critical factors in designing a water-based fire protection system. Supply source network. The water for a pump system may come from a deep well or from a surface source such as a lake, river, or reservoir. The supply is located at a lower elevation than the location it serves. It requires a pump to generate sufficient suction pressure to draw the water into the supply network. You may also have the water supply for a gravity system, which is stored at a higher elevation than the location it serves. This eliminates the need for pumping equipment. The water flows into the network at sufficient pressures on its own. You may also have a combined system that uses both gravity and pumps. Pumps fill water towers or other types of storage tanks. This water is fed into the system by means of gravity. The majority of water systems treat the source water, making it drinkable, before feeding it into the distribution network. From the water supply network, the water flows into a distribution network. The water main piping, which consists of transmission lines, distribution lines, and service lines. Transmission mains that are made up of very large piping transport a bulk of the water into an area of a city or a community. They can be many different feet in diameter. Distribution mains that are smaller than the transmission mains take the water from the transmission mains to supply a number of small areas within the system. Then you have these service lateral lines that take the water from the distribution mains to individual properties for domestic, commercial, industrial, in fire protection systems use as fire hydrants and water storage facilities. For a distribution network to be most effective, the water should flow from multiple directions to any point within the system. Transmission and distribution mains can be connected together to form loops or grids. Service lateral lines that feed water-based fire protection systems are often referred to as fire lines, fire mains, or private fire service mains. These lines tap off distribution mains and directly connect to the water-based fire protection system or hydrant. Many water system maps clearly mark these lines with a FL for fire line or FM for fire main. Although most water purveyors require a separate fire line for protection systems, some buildings have only one water line to supply both the domestic and fire protection needs. In new installations, the water company or contractor taps into a distribution line and then installs a control valve and enough piping to reach the property line of the project where the line terminates. From the termination, the developer might install distribution mains and secondary mains for the domestic water lines, and fire hydrants within the development site. Commonly used construction materials for new water lines include ductile iron, polyethylene plastic, and polyvinyl chloride, and other specific materials for specific situations. Materials are chosen based on system requirements and the possibility of corrosion. Water line installation, inspection, testing, and maintenance. Requirements for fire main installed on public water systems can usually be found in local draft and adopted civil engineering documents or NFPA 24, the standard for the installation of private fire service mains and their appurtenances. The approving authority or third-party engineer usually handles all the inspection, testing, and certification of new public and private water lines, including visual inspection of material and securing methods, hydrostatic pressure testing, line flushing, and disinfection. On a private property, the responsibility to inspect, test, and maintain all secondary feeders and distributor lines, including fire lines and hydrants, typically shift to the property owner. Water distribution system valves. Valves that control water flow from public water systems. Valves are used to facilitate shutdown and isolate sections of a network for repair or maintenance. The gate valve is the most commonly installed control valve. It's usually buried under streets, public right-of-ways, or the ground. Access requires removing the lid or cover of a valve box or a roadway box. A street key or a T-wrench or a valve key is necessary to open and close the valve. A non-indicating valve is another valve. A person cannot look at the valve and determine if it's open, partially open, or closed. Valves can open left or open right. A person must observe the effects on flowing water to determine if the valve is open or closed. By using the following general formula, it is possible to determine if the valve is fully open, partially open, or closed. The valve side in inches times 3 plus 2 will equal the number of turns to fully open or close the valve. Again, the valve size in inches times 3 plus 2 equals the number of turns to fully open or close the valve. When a water-based fire protection system or fire hydrant takes water from a public water distribution system, a non-indicating gate valve may be installed to provide isolation between the public system and the fire line feeding the system or hydrant. Some valves that control water flow from private water systems. First is an indicating valve, which allows a person to look at the valve and determine whether it is open, partially open, or closed. They are very helpful when performing periodic inspections. Post indicator valve, abbreviated SPIVs. They have a freestanding post that houses the stem extension of an underground valve. They indicate the position of the valve through a window on the post with the words open or shut. If one of the words is fully visible, then the valve is fully in that position. Operation of the valve requires a special wrench that is attached to the top of the valve nut and hangs down the side of the post. Often, this is secured with a lock. Another indicator is a wall post indicator valve. It is used in situations where it is impossible or impractical to install a freestanding PIV. Yet, the requirements for some type of indicating valves remain. Mechanically, the wall post indicating valve is similar to the post indicating valve, but instead of sticking out of the ground, it is mounted on the side of a building, with a valve stem feeding through the wall. Another valve is an outside screw and yoke, known as an OS&Y valve. It is operated by turning the wheel attached to a yoke coupled to a thread stem. When the wheel is turned, the stem rises or falls according to the turning direction and the position the gate within the valve. The wheel is marked with an arrow indicating the direction to turn to open and close the valve. When the threads are fully exposed, meaning you can see them, the valve is completely open. If no threads are visible, then the valve is fully closed. These valves are often found in underground valve pits or vaults. Let's look at some valves that control the direction of water flow now. Check valves and backflow prevention devices prevent water from flowing in the wrong direction and prevent potable and non-potable water from mixing. Both public and private water systems use these check valves and backflow prevention devices, which permit water to flow in only one direction. Check valves prevent water from flowing out of the system and back into the network. These valves have a plate or a disc inside their body called a clapper. When the pressure on the system side is higher than the supply side, the clapper swings back in the opposite direction and closes. If the flow and pressure equalizes on each side, the clapper will rest on the valve seat. These valves alone offer little, if any, protection against contamination of the water supply. The backflow prevention devices. These are double check valve assemblies. These devices contain two independent spring-loaded check valves that open when there is 1 pound per square inch of pressure difference between the flow. The first check valve closes if there is a back siphonage due to reverse flow. The second valve closes when the back pressure occurs. The double detector check valve assembly is another one. This device is similar to the double check valve assembly except that it has a water meter assembly attached to the bottom. Finally, you have the reduced pressure zone principal backflow prevention device. In addition to the two spring loaded check valve, this device has a diaphragm based spring and a load relief valve located between the check valves. This device offers the highest level of protection because the relief valve opens and drains to the atmosphere, even if both the check valves fail to operate. It does require periodic inspection, testing, and service to ensure proper operation. These valves are essential to keeping our water system safe and free of contamination. The fire hydrant is one of the most important parts of any water distribution network. It supports manual firefighting operations by providing a point of connectivity to the water supply. To connect fire hoses to the hose nozzle on the fire hydrant, the caps on the hydrant must be removed with a hydrant wrench. Water flows from the hydrant onto the fire apparatus pumper. The operation determines pressure flow and requirements and uses a pump to supply the water to the fire hoses lines or the FDC that is feeding the fire protection systems. Local building and fire codes establish the required location and the number of hydrants in a community. Most jurisdictions require hydrants where streets intersect and within 100 feet of a fire department connection. The distance from hydrant to hydrant exceeds a maximum interval. Types of hydrants. You have dry barrel and wet barrel hydrants depending on the climate. Dry barrel hydrants hold water that feeds the hydrant in the ground and below the frost line until the hydrant is open. When operated, it must either fully open or fully close to prevent water flowing out of the drain located at the base of the hydrant. The hydrant should be open or closed at a manageable rate to prevent a water hammer. These are commonly found where the temperature drops below freezing. Wet barrel hydrants contain water in the barrel at all times and are commonly found in areas where temperatures remain above freezing. A separate valve controls each outlet, so connecting the hydrant does not require turning the entire hydrant. A main control valve shuts down all nozzles. Both types have one large nozzle, known as a steamer nozzle, typically between 4 and 5 inches in diameter, and two smaller nozzles, typically 2.5 inches in diameter. The local fire departments determines the types of threads used on the hydrant. Bollards can be installed around the hydrant to protect them against vehicle strikes. These barriers must allow full access to operate the hydrant. Hydrants typically can also break away from their base. Wall, flush, and yard hydrants. Wall hydrant is installed on a structure such as a blank wall at a location where exposures to fire and falling debris is minimal. The flush hydrant may be installed in a below-ground vault or a pit and is commonly found on the runway at airports. A yard hydrant is commonly found in industrial facilities where fire brigades operate on a regular basis. Many jurisdictions paint their hydrant barrels one color and the caps and bonnets a different color. This can be for easy identification by the approaching apparatus. They may also correspond to a color code that indicates an expected water flow range. Typically, the cap and bonnet color, not the barrel color, corresponds to the flow rate. Some localities use different color codes for public, private, and non-potable hydrants. Many jurisdictions with significant snowfall and other environmental conditions mark hydrants with a locator flag that attaches to the hydrant by a spring-loaded wire pole, so they may be found Hydrant inspection, testing, maintenance, and service. Just like water supply lines, new fire hydrants require different inspections and tests to ensure they operate as required when needed. The tests for new hydrants are very similar to those for water lines. You have visual inspections of pipe material, bedding material, and securing maintenance. You have hydrostatic pressure tests to ensure there are no leaks. The line must be flushed to get rid of dirt, rocks, and debris that may be inside the pipe and hydrant. They are also flow tested and disinfected to kill bacteria. Once installed, fire hydrants need periodic inspection, testing, maintenance, and service to ensure proper operation. Making sure that the hydrant is accessible, checking the hydrant for damage, and the body and hose and threads all make up this inspection. They also need to make sure the hydrant operates properly and make sure there are no worn parts. Hydrant maintenance consists of the following: painting and repainting when necessary, cleaning threads, and lubricating the stem, caps, plugs, and threads. One of the first tasks when planning the design and installation of a water-based protection system is to obtain water pressure and flow readings from the water source that will supply the system. Once these readings are obtained, the system supply is evaluated for adequacy, flow pressure, and duration. Compare the readings to the information found in NFPA 11, NFPA 13, and NFPA 750. Verify the available pressure, flow, and duration will meet or exceed the required demands. One of the most important tests to ensure an adequate water supply is a flow test. The test is performed to ensure that the water supply is adequate to meet the flow pressures and the duration of a water-based fire protection system design. It can be as simple as opening a 2-inch drain on a fire sprinkler system, or as involved as conducting a fire pump flow test. For the purpose of designing a system for a new structure, a fire hydrant flow test are the most commonly used. These tests require special equipment, information concerning the distribution system, and knowledge of the testing procedures. When upgrading existing water-based fire protection systems in a structure containing a fire pump, it is more common to use fire pump performance test or the 2-inch drain test. Many times, flow testing reveals one or more of these variables as deficient for the required demand. Further testing might help to determine if there are impairments to the system or if the system needs to be reevaluated. Depending on the deficiency, different options are available, such as increasing the size of the system piping to provide more flow, installing water storage tanks to provide supplemental water to improve duration, or installing a pump to boost the water pressure. Water pressurization. Whether pressure is constant or varied within the system, the fire protection system design professional must determine if the pressure is adequate to support the design in that part of the community. The system design professional must know the static pressure and residual pressure, as well as the flow rate at the residual pressure. If the residual pressure is determined to be insufficient, installation of gravity tanks, pressure tanks, or stationary fire pumps can support the municipality, network, water supply, or natural resources. Gravity and pressure tanks. A gravity tank or elevated tank is a freestanding tank that rises above the ground in a community or industrial area. They can serve the community water supply or just the fire protection needs in a commercial or industrial settings. Tank capacity can be relatively small, such as 50,000 gallons, or very large, 500,000 gallons. They are engineered to withstand constant changing environmental conditions. Water in public tanks keep fresh water moving, but water in private tanks will stagnate. In general, tanks are used to supplement the supply of water when the distribution system cannot meet the instantaneous fire flow demands needed to fight fire. They provide an automatic, reliable, and positive pressure water source. As the tank's height above the ground increases, so does its pressure at ground level. Pressure tanks use compressed air to push water out of the tank and into the water-based fire protection system. These tank sizes generally range from 2,000 to 9,000 gallons, with water making up 2/3 of the total capacity and air the last third. Water supply must be capable of replenishing the tanks within 4 hours. The best location for a pressure tank is above the system piping, but some are installed below grade level. Stationary fire pumps. When water-based fire protection systems have adequate supply but need additional pressure and flow of water, the stationary pump is usually the first and obvious option. The fire pump has replaced the gravity tank and water booster pumps as the most common method used to pressurize a water-based fire protection system. Fire pumps take water from a source and boost the pressure to the desired level. Additionally, a fire pump delivers a certain amount of flow to the water-based fire protection system. There are different categories of stationary fire pumps. In the past, pumps fell into 3 categories: fire pumps, booster pumps, or special fire service pumps. Distinction between whether the water source was under pressure or whether the pump generated all of the pressure. Today, the term fire pump describes any of the different pump categories. Installation requirements are pretty much the same for each category of the pump. Certain pumps categorized as fire pumps are technically booster pumps. Types and styles of stationary fire pumps. First, you have a centrifugal pump that creates pressure by drawing water into the center of a precision manufactured disc-shaped piece of metal called the impeller, basically consisting of what is known as the eye, vanes, and shrouds. By far, the centrifuge-type pump is the most widely installed stationary fire pump. It is available in different styles, including horizontal, vertical, split case, in suction, vertical inline, and vertical shaft turbines. Another pump is a positive displacement pump, which are more commonly found on fire apparatus. They are suited for water-based fire protection system applications, including foam, water system, and water mist systems. These pumps operate at a specific speed to deliver a predetermined pressure and constant rate of flow. Positive displacement pumps are well suited for high pressure applications, but unlike the centrifuge pumps, they can build unwanted pressure on the discharge side of the pump. They are well suited for high pressure applications, but should be equipped with an internal or external pressure release mechanism on the discharge side of the pump. Performance rating characteristics. The flow and pressure reading established the rated performance, which is the basis for the overall performance characteristics of the pump. The performance criteria are stated in gallons of water flowing, GPM, at predetermined pressures, PSI. The ability to pump is determined by comparing the rated flow and pressure readings with 2 other specific performance points on a graph to create a performance characteristic discharge curve. Churn measurements, also called shut-off, minimum, deadheading, or no flow, are taken when the pump is running at rated speeds with no water flow. Peak performance, also called maximum or overload point, is actually 150% of the rated flow at 65% of the rated pressure. Certain performance curves establish the pump's performance capability and is specific to the fire pump. The name or data plate attached to the pump states all the important pump performance information and functions. Fire pump assembly components. Made up of components that function as a unit to connect and control water flow. They provide the pump's power, monitor and control pump operations, and provide opportunities to verify pump performance. First, you have drivers, which provide the power to turn the pump. The type is determined by performance requirements, the availability of reliable electric power, insurance requirement, space, cost, and the availability of a particular resource. Drivers can be electric, steam, gasoline, or diesel power. Next, you have controllers. They are the brain for the fire pump system. They perform logic, sensing, and supervisory functions. They require certification for fire service duty. It must be installed in the room and as close to the pump and driver as is practical. They may start the fire pump electrically from a remote location or upon activation of a fire protection system. Many use electronic and microprocessor-based technology to control, monitor, and store information. This results in less dependency on mechanical components that are more prone to fail. Typically, have a runtime so that even if the system pressure stabilizes, the pump will continue to run for a predetermined amount of time, unless manually stopped. They are configured differently depending on the type of the drive motor, and they may be full service or limited service. Transfer switch. Facilities change the normal power source to the backup source. Monitors for both the normal and backup power source for issues such as voltage drop, proper frequency, automatic transfer back to the normal power source, generator start, and generator shutdown delay. They are part of the pump assembly. Jockey or pressure maintenance pumps. They manage the pressure loss on wet pipe fire protection systems. They connect to an electric motor and operate by a pressure starter switch. They can boost and maintain the system pressure above the fire pump starting pressure settings. It is set up to monitor normal system pressure and change due to components such as fittings, pipe leak, or changes in temperature. If running frequently, this may be a sign of a significant leak or a problem with the pressure starter switch. Control valve must be an indicating type valve. It must be supervised by one of the methods listed in NFPA 20, such as electronic monitoring, lock, or sealing the valve or limiting access in conjunction with weekly inspections. They are typically installed on the suction and discharge side of the fire and jockey pumps. All should be kept in the open position. The main relief valve is located on the discharge side of the pump and is required when the pump driver operates at a constant speed. When the suction and churn pressures are greater than the pressure rating of the component, or when there is an adjustable speed driver. The circulating or casting relief valve is located on the discharge side of the pump and prevents the pump from overheating when no water is flowing. The automatic release valve sits on top of the pump and vents air that has entered the pump casing or discharge head. Next, you have bypass. Provide a pipe path around the pump in case the pump fails to operate. Requires water control valves and check valves that prevent water from flowing back into the water supply systems. They should remain open and only be closed when the check valve requires maintenance or service. Test head and flow meters. When discharging water out of a system, the test header provides hose valve outlets. It facilitates flow and pressure management when the test equipped. A significant amount of water is flowing, so it is important to consider how to manage and dispose of the water. When testing the pump by circulating water through the system, a flow meter measures the fire pump water flow. All flow meters are installed in line with the system piping and measures water as it flows from the discharge side to the pump back to the source. Gauges. They are required on the suction and discharge side of a fire pump. They must be at least 3.5 inches in diameter and equipped with a gauge valve to facilitate gauge removal for replacement or calibration. Eccentric or concentric reducers and increasers. They are used when cavitation is caused by the fire pump suctioning and discharge flanges being a different size than the system piping. They ensure that the water flow in and out of the pump without creating turbulence that would cause air pockets, rendering the system inoperable. Fire pump operation. A fire pump operates when there is sufficient loss of water pressure in the connected fire protection system. Both jockey and fire pumps detect pressure changes through 1/2 inch normal size pressure sensing steel pipes or tubes that tap into the piping between each pump discharge, check valve, and discharge control valve. The pressure setting that signals the jockey pump to start is the Ch05 pressure of the fire pump plus the incoming water supply pressure minus 10. Fire pump inspection, testing, maintenance, and service. First, you will have an acceptance test, which is made up of flushing the incoming suction side supply line before the pump connects to the suction piping, performing a 2-hour hydrostatic pressure test, a visual inspection of the fire pump assembly, and performing a field acceptance test. Periodic inspection, testing, maintenance, and service. It is composed of exercising the fire pump with electric drivers for 30 minutes a week with no water flow and flow testing annually. Summary. In most populated areas of the country, the water supply system is typically controlled by a public utility, a local or state government or regional water authority. These organizations are responsible for the engineering, maintenance, and management of the municipal or public water system. The water supply system is divided into supply, source network, and the distribution network. The supply source network takes the water into the system, treats and purifies it, and then sends it into the distribution network for storage and delivery purposes. The water supply system supplies water for a community's domestic, commercial, industrial, and fire protection needs. In addition, it supplies water to privately owned water systems that support fire hydrants and water-based fire protection systems. Dedicated wire lines, called fire lines or fire mains, connect the water supply to hydrants and fire protection systems. These lines should only supply the intended fire protection system because their size must be adequate to meet the system demand. Various types of valves control water flow and the direction of water flow. These valves include non-indicating valves, indicating valves, check valves, and backflow prevention devices. Fire hydrants offer firefighters a ready water source for manual firefighting. Most jurisdictions require a hydrant where streets intersect and where the distance from the hydrant to hydrant exceeds a maximum interval, and within 100 feet of a fire department connection. The two most prominent types of hydrants are the dry barrel, installed where the temperature falls below freezing, and the wet barrel, installed where the temperature remains above freezing. Water flow tests are used by the fire protection engineers and design professionals to determine if the water, pressure, flow, and duration adequately meet the design requirements of various types of water-based fire protection systems. These tests might involve a 2-inch drain, a fire hydrant, or a fire pump. To overcome pressure problems, design professionals utilize gravity tanks, pressure tanks, or fire pumps to provide the needed pressure boost so the system will operate at the required performance level. There are two types of fire pumps listed or approved for fire service duty, and that is the centrifugal and positive displacement. The centrifugal pump is the most common type of pump installed to support water-based fire protection systems. The positive displacement pump is the best choice for foam and water mist systems where a constant flow and pressure are necessary to protect the hazard. A fire pump is part of an ensemble of components, which includes a controller and a driver. Other important components of the assembly include the transfer switch, pressure maintenance pump, relief valves, test header, and eccentric and concentric reducers and increasers. Okay, gang, we covered a lot in this chapter. Make sure you read, understand, and take care of doing the review questions. If you have any questions, you can call me in the office at 706-357-0162, or you can email me at aroberts@athenstech.edu. Until next time, have a great day.